we're going to take a look at our practice of all of these discrete random variables and combining several variables and making sure that we are transforming first before we combine so that we take those we get those special rules correct. Okay, so this first one asked us to complete a probability distribution of the expected number, the expected face value on a die. So that's what that is. That's what that table is that probability distribution. So you're saying what the face values are and then the probability of those. They were equally likely. So then the mean would be, the first value times its probability plus all the way up to the last one times its probability. Now, remember that you can do this sequence if you have the table drawn out, which makes it easier here on this standard deviation. It is your x minus the mean that you had just computed here, quantity squared times its probability, up to the last one, which was your 6 minus the mean, quantity squared times the probability. All right. So now what happens if you do 3 tosses? Okay, so then that is combining 3 times together. Well, means combine like normal. But standard deviations have to go through that Pythagorean theorem of statistics. So it's that standard deviation squared plus standard deviation squared plus standard deviation squared, square rooting it. All right. Next, we have two different situations. Okay, so we've got this situation where we have the number of, or the daily cost, okay, and then we're transforming it into a weekly cost. So, what you really should do first is transform first and then combine the husband and the wife. So, I'm going to transform it into a weekly cost first for the husband and the wife, and then I'm going to combine. So for means and standard deviations, multiplying times 5 is good to go. Multiplying times 5 for standard deviation as well. So then when I combine the husband and wife, they add together to be $60. And this standard deviation, of course, Pythagorean theorem of these two values of their weekly costs. Now, I mentioned this alternative way, but it only works. Again, it only is working because and can go this way where you combine the husband and wife first, um, and then combine their standard deviations first. The only reason this works is because the husband transformation was 5 days and the wife's transformation was 5 days. So the reason that it happened to work as well whenever if you combined first and then transformed was because the transformation was the same for both of them. Okay? If it's not the same for both of them, then you need to do the other way. All right. Next, here we are just going through this transformation of the 2x plus 3y. So we have a transformation. We want to do the transformation first. 2 times the mean plus 3 times that. And then, I actually thought that without context, this problem needed some clarity. I couldn't tell if it meant if this was a transformation or if it was combining 2 of the x's plus 3 of the y's. So, I guess that you really truthfully could have possibly done this standard deviation differently. But I'm just going to leave this right here. I did this problem as if there were 2 of the standard deviations squared plus 3 of the y's squared, wide standard deviations squared. Okay. All right. Now we have this problem. This came from an actual AP question. Okay. So we were combining the total weight of 2 vegan meals, 3 paleo, and 2 keto. Now it did ask for expected and standard deviation. So I want 2 of the vegan plus, so let's see. So this was, yeah, so this is just a combining. There wasn't a transformation. It was combining 2 of the vegan, 3 of the paleo, and 2 of the keto. Okay. So then whenever I'm doing my standard deviation, it's 2 of the standard deviation squared for vegan, 3 of the standard deviation squared for paleo, and 2 of the standard deviations squared for keto. Okay. Combining multiple standard deviations. All right. Now we have this situation where we are having to, this is interesting. Okay. So here, there's kind of a bit involved with this one. So we have a factory and we know that they're making all these different shirts. And, so you're going to have to keep the units clear to understand this problem. So, first, for the different shirts, they have different numbers of buttons per shirt. Okay. And then they are doing different, this company, this factory has makes a different proportion of shirts. So 23% of the shirts, 26% of the shirts are Ralph Lauren, 18% are Banana Republic, and so on and so forth. Okay. So since we're dealing with just the average, then it is okay. We're going to go ahead and come up with that mean of the 10 buttons per shirt. Okay. And then times the percent of time, the frequency that happens. So 10 buttons per shirt times that frequency, and so on and so forth. Okay. So then this is the average number of buttons per shirt that they do across their entire company, their entire factory. And then we know the cost per shirt due to the buttons. So once I know on average the number of buttons per shirt that this factory makes, then I did this combining or this multiplication. So I think actually, if I was to keep the rule the same where I transform first and then combine, then I would just have multiplied these numbers here 10, 12, 8, 8, and 12 times zero point zero 0.06. And I should have gotten those numbers first by multiplying and then done the combining of the frequency that those costs happen. So that cost times 0.23 and so on. That would have made a difference if we were doing standard deviation, but thankfully we were not. So I had that freedom to change the order on mean. All right, but this one, super duper important. Transform, because what we have is cards, and then we're getting points for those various cards that we have left in the hand. So I first came up with the point values that we have, because ultimately, what's the expected number and standard deviation of points left in the player's hand? So I want to come up with the points first. So then the means will combine like normal, but the standard deviations combinations are going to be trickier, see? So we are transforming into points first. 32, 30. So it was based on what the rule was stated up here or down here. 10 per X card, 5 per non-face black card, and -5 per non-face red card. Okay. So then we do our combining. Once we have transformed it into points, now combine. The mean combines like normal, okay? And the standard deviation then is doing that Pythagorean theorem of statistics to combine. Okay, I guess that was it. Was there another one down there maybe? Oh yeah. There's a number 7. Okay, and this one was an actual AP multiple choice question. Okay, so what I did was I kind of determined. I first, I guess, wrote out just because there was so much words here, so I wanted to kind of organize it. So I had a mean and a standard deviation for the northern farm, a mean and a standard deviation for the western farm. Okay, and then they had 10. Oh, here we go. This one was asking for standard deviation only. So see, this was the Pythagorean theorem thing. So I want 10 of those northern variances. So that's 10. I'm combining 10 of those. This is not a transformation where I'm doing 10 times 1.3 first. No, I want 10 of the 1.3 squareds plus 15 of the 0.5s squared. Okay, so this was a combining 10 of the northern ones with 15 of the western ones, not a transforming, combining those many variances. So that's why it was C. All right. Okay, I hope that that cleared up some things for you. And this is the end of our discrete random variables. So then you're just going to do the warm up so that you're prepared for our quiz tomorrow.